Hey guys, so let's take a look at this delta thing. And if we scrub through the timeline, you can see points are changing over time. We're getting new points added, new points removed, and some points are being removed, but some data is staying the same. Here, like this edge, for example, is on for a couple of frames, maybe this part. So it's on for a couple of frames, but data around it is changing back and forth. So what I want to do is I'm going to create an attribute and call it delta. As an integer, delta is equal to 0. And then I'm going to do a time shift and move 3 frames ahead. Now at this point, if we compare, at this point, if we look at the number of points, it's 589, and here it's 6,246. So we have different point counts. So some points have been added, some points have been removed, but some stayed the same. Between this and this, there's points that are the same. And we want to flag those. We want to know which points have stayed on for 3 frames, which points at this state that still exist after 3 frames. So we're going to copy this delta and change it to 1. Okay, and then I'm going to use an attribute copy. And remember, we have an ID attribute. We don't have an ID attribute, so let's make one. So I'm going to create an ID attribute to allow me to track the points. So here, ID, well, at ptnum. Okay, so we have the same ID. We can track the points with that. And I'm going to copy the delta back into the geometry. So the attribute is delta, and the match by is ID. Now here we have points, and then here we have a different set of points that some are present in the first frame, in the original frame, but others are present as well. They continue to be present in the next 3 frames. And when we copy this delta back, we are only changing the value on the points that existed at this frame. Okay, because this copy is not going to change the 0 value, it's only going to override the values that are 1. So if I do a blast node now and say add delta equal 1, and it's a point, attribute, you can see we lost points, and those points are actually the only one that stayed on for 3 frames. If we compare this, those are the only points that stayed, and that's what we're deleting. If I do delete non-selected, then we're only keeping things that are stayed for too long, and we don't want that. So I'm gonna uncheck this, and now the edge will be only on for 3 frames. Okay, even if it's still too close, it's gonna be on for 3 frames only. It might come back again, but I think it's perfectly fine. You see here, for example, it's going to be on 1, 2, 3, and then done. And you can change this. You can lower the time shift to be 1 frame or 2 frames, and that's going to give you the flickering effect. So even if something is on for too long, you can delete it after 2 or 3 frames. And that's basically the delta approach. And then I'm going to delete the attributes just to clean this up. But I'm going to delete anything that is not needed, like all this. I'm going to keep the ID and the name attribute probably, and the velocity. And I'm going to write this to disk, and this is how it looks like. And so that's the separation attribute. And you can see it's perfectly, you can clearly see the motion in there. See? That's the second hit from IREX, and this is the original sim. Maybe let me show. So this part here. And that's the emission. Yeah. And this was really fast to sim. I think the slowest part was to generate the wires. Okay, and maybe the deformation here, but everything else after that is really fast to work with. And that's it. And we have the velocity vector, so we know how fast the pieces are moving. And let's do this. Let's just create a pop network. And I'm gonna dive inside. I'm not gonna do anything. I'm just gonna hit play. And let's change this to all points. And that's our first particle sim from the source. Right now it's using the velocity inherited, which is quite strong. So I'm gonna lower this to 0.05. And let's add a pop drag of 0.25. Let's add a gravity node, and let's add a ground. Let's merge all of this. And let's hit play. Sorry, I'm not looking at the gravity. Okay. And that's our first debris emission. I'm gonna change one thing quickly just to get a more interesting preview. I'm gonna change the interpolation source to forward, and I'm gonna use point velocity. That way it's gonna help, it's gonna help break that continuous emission. And let's keep on some velocity. I think we lost too much. Yeah, we want some explosiveness. And let's do a quick dirty thing. I'm going to use a particle fluid surface node. Change this to particle. And I'm going to visualize using the velocity. And let's import the data. Dop import. Fetch geometry from dops. And let's use the velocity as a way to visualize this. That's our first dust or debris sim. And because of this scale, we definitely need an airfield so that when Kong moves through all these particles, we see interaction, not just collision, but if his hand is dragging through this, we want to, cause everything else to swirl. So that's the effect that we're aiming at creating. And that's pretty much it for the separation. Next is we're going to create the intersection, and my idea is I want to prep the two sources. So the first one is done, then we're going to prep the second source and create one particle sim that can be replicated to the other emitter as well. And we're going to look at the collision, cover pretty much everything. Then we're going to create the airfields and apply those back onto the sim. Thank you guys for watching, and see you in a bit.